the last couple of decades, climate change has really loomed as an imminent problem for coral reefs. Corals in particular are really quite susceptible to a changing climate. All over the world there's been mass coral bleaching events, and it's for this reason that corals of the Kimberley are particularly fascinating. As you can see, at low tide they're exposed 3 or 4 meters out of the water. Normally at high tide the water would be right above us. Yet the corals of the Kimberley appear very, very hardy and very, very tolerant of these extreme conditions. So very high sea surface temperatures, very high daily temperatures, and very high light exposures. So it's clear that there's some special biological adaptations that have occurred in the corals of the Kimberley that helps them to survive these extreme conditions. So I'm particularly interested in investigating these biological adaptations. And right here today we've found something that gives us a little bit of a hint into one of these possible adaptations. See, here is a Parades microatoll. So ordinarily this coral will be this yellow colour, but as you can see on the top here where the coral is exposed, it is pink. So what I'm proposing this is an expression of a fluorescent protein that will have a photoprotective role. So it's obviously able to reflect the light better, and it helps the exposed part of the colony survive these extreme conditions. So presently nothing is known about the pigments of corals of the Kimberley, but in other locations the pigments have proven very, very interesting, and they're used in biomedical imaging and other types of cell biology research. Also, what corals have is a sunscreen, a natural sunscreen in their mucus. So combined with the fluorescent pigments and proteins and their sunscreen properties, corals really do seem to have worked out how to cope with these conditions up here in the Kimberley.